Okay, welcome back to Math Myers. We're in Unit 6. We're proving that a quadrilateral is a parallelogram. We spoke about the four major properties, and those major properties are, and we have to commit these to memory. Opposite sides are congruent. Let's see what's hiding over here. The diagonals bisect each other. What else could we pull up? Opposite angles are congruent, and consecutive angles are supplementary. Okay, folks, the question here is this figure a parallelogram? Well, let me add some things to this. I want to say this angle right here is 90 degrees. This is 90, 90, and 90. I'm going to say that this side here is 12 inches, and this is 5 inches, and this is 12 inches, okay? So let's think about it. Are opposite sides congruent? So, yes, opposite sides are congruent. So I could put a check beside that. Okay. Are opposite angles congruent? Yes, I see 90 and across. I see 90, 90, and 90. Opposite angles are congruent. All right, let's check out our consecutive angles equal to 180. Well, what's consecutive right next to or on the same side? So let's look at this. Here's 90. What is 90 right next to? 90. And they do add up to 180. Let's check the other one out. Okay, we have 90 here and we have 90 here. They're right next to each other. And they add up to 180. So I will say that checks out that consecutive angles are supplementary. Okay, last but not, let's see if the diagonals bisect each other. We know that this word bisect means that when they cross or cut, they are equal. So if I go from here across, I notice my tick marks, and they are definitely equal. So guess what, folks? This figure, yes, is definitely a parallelogram. Okay, there's something else that we need to talk about with parallel lines. When parallel lines cross by transversals and segments are made by those parallel lines. Okay, segments are made by parallel lines. We definitely know that corresponding angles are congruent. So this angle is congruent to this angle, is congruent to this angle. But we actually aren't talking about angles. We want to talk about the segment. So if I measure, folks, here from F to E, and this distance from F to E is 5 inches, and this distance right here from E to D is 5 inches, then the segments that are made over here are also going to be the same. So if A to B is, let's say, 7 inches, what do you think it is from B to C? You guessed it, x is equal to 7. So what do we know about this? If we have parallel lines that are crossed by transversals and the sections are of equal distance, then the other transversal would definitely make equal segments as well. How can we use this? Okay, segments made by parallel lines. Here are some applications. Down here, folks, you can clearly see that the three questions are, what is DF? And without a bar, we say that's the distance or the length of the segment, DF. I want to know what X is, and I want to know the distance from A to C. So D to F, from D to F, I know that from D to E is 9 inches. So that means that parallel lines sectioned off are going to make congruent sections. So I know this is 9. So to go from D to F, it's 9 plus 9. So D to F is 18 inches. Next, let's find out what X is. Well, X is right here representing BC, 10x plus 3. But I know that AB is 12. So I will set this up. BC is going to be equal to AB. Next step is substitution. BC is 10x plus 3, and AB is 12. So I add 3 to both sides, and I get 10x is equal to 15. I divide by 10, divide by 10. And x is equal to 3 halves. I come over here and I write x is equal to 3 halves. Now I need to find out what AC is. Well, some people may say substitute, but I'm not. If A to B is 12, then guess what? B to C is also 12. So A to C is 12 plus 12, which is 24 inches. This is what we do when parallel lines are crossed by transversals and they make even sections. Okay, here we go. As we can see here, we notice that we have some parallel lines. And how do we know they're parallel lines? Because we definitely notice the arrowheads right here. We see the arrowheads, we see the arrowhead here, and an arrowhead here. So they're definitely parallel lines, okay? And they are sectioned off by transversals. So the direction says in the figure, TU is equal to UV. That's important because we have to start off with some congruent parts. Therefore, we know the parallel lines are evenly spread apart. Finally, of each segment. So we're going to start off with NM from here to here. Now that should be congruent to ML, and from M to L it is 4.5. So this is 4.5 units. Okay. Let's try another one. Let's see what it is from Q to S. Well, from Q to S, here's Q to R, here's R to S. So Q to S is going to be 3.8 and 3.8, which is going to be 7.6 units. Okay, easy enough. Folks, you can try the rest on your own. In your textbook that you have, there's some book practice, and that book practice is page 364, 17 through 24. And guess what? This concludes and has been the shortest video. All right. See you next time, and don't forget to come back tomorrow and watch the next video on placing figures in the coordinate plane.